Hello everyone, myself Vinay Kumaram. I'm pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous videos, I was actually discussing about the second maths chapter in 9th standard that was on polynomials. So I have covered most of the introductory topics about polynomials, and I have also done exercise 2.1 and 2.2. So in this particular video, we will try to understand exercise 2.3. So before this, in my previous video, I have also explained about factor theorem and remainder theorem. So, and also I have explained how to factorize a particular polynomial either by using splitting method or by using factor theorem. So please do refer that particular video to understand about factor theorem and then come to this particular video to solve exercise 2.3 questions. So now we will look into the exercise 2.3. So now coming into the first question in this exercise 2.3, here you have certain polynomials given and they have asked x plus 1 is factor of this polynomials or not. So x plus 1 is factor or not of the following polynomials. So the first polynomial which they have given here is x cube plus x square plus x plus 1. So here x plus 1 is there, means x plus 1, I can write this x plus 1 as x minus of minus 1. So according to factor theorem, if x minus a is the factor of a particular polynomial, then p of a should be 0. So that means here a is equal to minus 1. That means p of minus 1 should be equal to 0. Then this particular x plus 1 will be the factor of this particular polynomial x cube plus x square plus x plus 1. So now we will try to find p of minus 1 for this particular polynomial. The polynomial is x cube plus x square plus x plus 1. I am just writing this polynomial once again. So p of minus 1, this minus 1 you have to substitute in this particular x position. So minus 1 whole cube plus minus 1 whole square plus minus 1 plus 1. So here minus 1 whole cube means it is minus into minus into minus. 3 times you have to multiply minus. So when you do 3 times multiplication of minus, you will get minus only, because minus into minus plus, plus into minus is minus. So minus 1 cube is 1. Here minus 1 into minus 1 is there. 2 times you have to multiply minus, that is minus into minus, that will be plus. 1 square is 1. So plus 1. Here minus is there, here outside plus is there. So plus into minus, it is minus. So minus 1 plus 1. So here you can see plus 1 minus 1 plus 1 minus 1 gets cancelled with each other and you are getting 0. So p of minus 1 is 0 means x minus of minus 1 is the factor of, so x minus of minus 1 is the factor of this particular polynomial x cube plus x square plus x plus 1. So this x minus of minus 1 means this is nothing but x plus 1. So x plus 1 is the factor of this particular polynomial x cube plus x square plus x plus 1. So this is first question. Now I will try to solve the third question in this particular first question, that is x power 4 plus 3x cube plus 3x square plus x plus 1. Here also you can check the p of minus 1. So substitute minus 1 over here. So minus 1 whole power 4 plus 3 into minus 1 whole power 3 plus 3 into minus 1 whole square plus of minus 1 plus 1. Now here you have 4 times you have to multiply minus. So that is minus into minus plus, plus into minus minus, minus into minus plus. So that means finally you will end up with plus only. So 1 power 4 is 1 plus 3 minus 1 whole cube is there, that is nothing but minus 1, because 3 times minus when you multiply it will be minus only, and 1 cube is 1. So minus 1 plus 3 into minus 1 whole square is there. So minus 1 into minus 1, minus into minus plus, so 1 into 1 is 1 only. So 3 into 1, here plus and minus is there, so plus into minus is minus, so minus 1, and at last you have plus 1, which is not equal to 0. So that means x plus 1 is not the factor of this particular polynomial. So that is third polynomial. So you can write x plus 1 is not the factor of x power 4 plus 3x cube plus 3x square plus x plus 1. So this particular third polynomial in first question, for this polynomial x plus 1 is not the factor because here p of minus 1 is not equal to 0. Now we'll go to the second question in this particular exercise 2.3. Here, using factor theorem, you have to determine whether g of x is a factor of p of x in each of the following cases. So that means here in each question they have given p of x, that is the main polynomial, and they have given the factor of that particular. We don't know whether that is factor or not. They have given another polynomial, that is g of x. So you have to tell whether that g of x, what they have given, is the factor of the polynomial which they have given. So in first question, commonly they gave one particular g of x, that is x plus 1, and for other polynomials you try to find out whether that particular x plus 1 is factor or not. Here for each polynomial they are giving one another polynomial, that you have to find out whether that particular g of x is the factor of p of x or not. So coming to the first question in second question, here p of x, what they have given is 2x cube plus x square minus 2x minus 1, and g of x, what they have given here is, that is nothing but you have to find whether this is the factor of this polynomial or not, that is x plus 1. So here g of x is x plus 1 means this particular x plus 1 can be written as x minus of minus 1. So now you have to check whether this x minus of minus 1 is the factor of this particular polynomial or not. So in order to do that, here you know this is in the form of x minus a. So this is in the form of x minus a. So here a is equal to minus 1. So that means p of a is nothing but p of minus 1, and you have to find out whether p of minus 1 is equal to 0 or not. So that is p of minus 1 is equal to, you have to substitute minus 1 in this particular x position. So we'll do that, 2 minus 1 whole cube plus minus 1 whole square minus 2 into minus 1, and at last you have minus 1. So now minus 1 cube is nothing but minus 1. So 2 into minus 1 is minus 2, plus here minus 1 square is there. So minus 1 into minus 1 is plus 1. So plus 1. Here minus 2 is there. Here minus 1 is there. So minus into minus plus 2 into 1 is 2. So plus 2 minus 1. So here minus 2 plus 2 gets cancelled with each other. Plus 1 and minus 1 gets cancelled with each other. So finally you are getting 0. So that means here this particular g of x, that is x plus 1, is the factor of this particular polynomial p of x, that is 2x cube plus x square minus 2x minus 1. So that means g of x, that is x plus 1, is the factor of this particular polynomial. In the same second question, we'll try to solve the second question. So that is p of x is equal to x cube plus 3x square plus 3x plus 1. This is the polynomial which you have, and g of x is equal to x plus 2. So here you have g of x as x plus 2. So x plus 2 you can write as x minus of minus 2. So that means I am writing this in the form of x minus a. Now you have to see p of a, whether it is equal to 0 or not. P of a means here in this case it is p of minus 2. So now we will try to calculate p of minus 2. In this x position you have to substitute minus 2. So p of minus 2 is minus 2 whole cube plus 3 into minus 2 whole square plus 3 into minus 2 plus 1. So here minus 2 3 times you have to multiply, minus 2 into minus 2 into minus 2. So that means here minus into minus into minus, that will be minus itself, because minus into minus is plus, plus into minus is minus. So that means first term is minus itself, 2 cube is 8, so minus 8. Here minus 2 whole square is there, so minus into minus becomes plus, 2 square is 4. So that means 4 into 3. So 3 into 4 is 12. Again here you have minus 2 into 3. So plus 3 into minus 2. So plus into minus is minus, 3 into 2 is 6 plus 1. Minus 8 plus 12 minus 6 plus 1 is there. So minus 8 minus 6 is minus 14. 12 plus 1 is 13. So that is minus 14 plus 13, which is equal to minus 1, which is not equal to 0. So that means this particular g of x, which is equal to x plus 2, is not the factor of this particular polynomial. So that means x plus 2 is not the factor of this x cube plus 3x square plus 3x plus 1. So x plus 2 is not the factor of this particular polynomial. So third question in this particular second question you can solve on your own. Now we will look into the third question of exercise 2.3. Here you have to find the value of k if x minus 1 is the factor of all these polynomials. So that means here they have given the factor. So this is the factor, and using this you have to find out the value of k. So according to factor theorem, if this x minus 1 is the factor, if this x minus 1 is the factor of a particular polynomial, then p of, here this particular factor is nothing but x minus a. So that means here p of a should be equal to 0. So that means here a is nothing but, here a is equal to 1. So that means p of 1 should be equal to 0, because they have given x minus 1 as the factor here. So now you have to, according to factor theorem, you have to take this p of 1 as 0. So if p of 1 is equal to 0 means you have to substitute 1 in the place of x, and you have to equate that to 0 and try to find the value of k. So now we will look into the first question in this particular third question, that is p of x is equal to x square plus x plus k. So here, since x minus 1 is the factor of this particular polynomial, so p of 1 will be equal to 0. So that is nothing but p of 1 is nothing but 1 square plus 1 plus k, which is equal to 0, because I am substituting 1 in the place of x. So 1 square plus 1 is nothing but 1 plus 1, that is 2, plus k is equal to 0. So k is equal to, when you bring this plus 2 to RHS, it will become minus 2. So k is equal to minus 2. So the value for k in this first question, for in this particular third question, is minus 2. Now we will look into the third question in this particular third question. So in this third question you have p of x is equal to kx square minus root 2x plus 1. So here also you have to find out the value of k, and here also x minus 1 is the factor of this particular polynomial. So that means p of 1 will be equal to 0. So here p of 1 means that is nothing but k into 1 square minus root 2 into 1 plus 1, which is equal to 0. So here k minus root 2 plus 1 is equal to 0. So now you can take this particular minus root 2 and plus 1 to RHS. So that means nothing but k is equal to 1 minus 1 plus root 2, because when minus root 2 go to RHS, it becomes plus root 2, and plus 1 when it goes to RHS, it becomes minus 1. So that means here k is equal to minus 1 plus root 2 means it is nothing but 1.414, and it goes on like this. So k is equal to 1.414 minus 1 is nothing but 0.414, and it goes on like this. So this is the value of k in this third question in third question. So now let us look into the fourth question. So second and fourth question in the third question you can solve on your own. Now we'll look into the fourth question of exercise 2.3. So in fourth question and fifth question, both they have given set of polynomials, and you have to factorize those polynomials. So you can use factor theorem to factorize these polynomials. So coming to the first question in fourth question, here you have 12x square minus 7x plus 1. How to use factor theorem? So just multiply this particular constant and the coefficient of x square. So now when you do that, that will be equal to, so this you can consider as a and this you can consider as b. So a into b is equal to 12. That is nothing but 12 into 1, which is 12 only. So now you have a into b. Now you should see that if you do a plus b, that should be equal to minus 7 as well. So you have to find out a and b. such a way that a into b should be equal to 12 and a plus b should be equal to minus 7. So in order to do that, you can take minus 3 and minus 4, because when you take minus 3 and minus 4, minus 3 plus of minus 4 is nothing but minus 7. So that means here you are doing a plus b. Similarly, when you do a into b, that is minus 3 into minus 4. So 4 into 3 is 12, minus into minus is plus. So that means plus 12. So here we are getting exactly what we want. So directly you can take this particular polynomial which they have given here, that is 12x square minus 7x plus 1. So straight away this particular minus 7x you can split as minus 3x plus of minus 4x. So 12x square minus 3x minus 4x plus 1. So now we have split this. So I'll write one more time. So p of x is 12x square minus 3x minus 4x plus 1. So here you can take 3x common. So when you take 3x common, what will be remaining? 4x will be remaining here, because here from 12 you are taking 3 and from this x square you are taking x outside. So that means here 4 will be remaining, x will be remaining. So 4x minus, here also you are taking 3x outside. So you are taking plus 3x outside. So minus 1 will be remaining inside, because 3x into minus 1 will become minus 3x. So here in these two terms you can take minus 1 common. So when you take minus 1 common, inside you will have plus 4x, because minus 1 into plus 4x will become minus 4x. Similarly, plus 1 becomes minus 1, because minus 1 into minus 1, again it becomes plus 1. So that's why when you take minus 1 common from this plus 1, it will become minus 1. So minus 1 into minus 1, again it will give you plus 1. So that means here minus 1 into 4x minus 1 we are getting. In this term and in this term, you can clearly see 4x minus 1 and 4x minus 1 is the common term. So when you take 4x minus 1 common, so 4x minus 1, inside bracket you will have this 3x minus 1. So 3x minus 1. So p of x you can write as 4x minus 1 and 3x minus into 3x minus 1. So that means here 4x minus 1 is one factor and 3x minus 1 is another factor of this particular p of x. Now in this fourth question, I'll try to solve the fourth question, because second question and third question are easy and you can solve on your own. Here also you have to take the multiplication of constant and the coefficient of x square, and you have to multiply, and you have to find those two numbers, that is a and b, where if you add them it should give you the coefficient of that particular middle term. Just like how I solved the first question, you can solve the second and third question. Similarly, you can solve the fourth question also. I'll solve this fourth question so that you will get better understanding of this factorization. So in fourth question, you have 3x square minus x minus 4. So in fourth question, I'm solving the fourth question. So 3x square minus x minus 4 is there. So here the coefficient of x square is 3 and you have minus 4 as the constant. So that means here a into b is equal to 3 into minus 4, which is equal to 4 3s are 12, minus plus into minus is minus, so minus 12. Now you have to find out a plus b. So in such a way that a plus b should be equal to minus 1. So here coefficient of this particular minus x is minus 1. So that's why a plus b should give you minus 1. So you should take those two numbers. So what numbers we can take for this? So here you can take 3 and minus 4 only. Because when you take 3 and minus 4, 3 into minus 4 will give you minus 12, and 3 plus minus 4, that is nothing but 3 minus 4 will give you minus 1. So here also you are getting minus 1 and this minus 12 also you are getting. So that means this minus x you can write as plus 3x and minus 4x. So now we'll write this once again. So p of x is equal to 3x square minus x minus 4. So this minus x you can write as plus 3x minus 4x minus 4, because plus 3 minus 4 means it will become minus 1. So that means minus x you will be getting back. So plus 3x minus 4x will give you minus x. Now you can take 3x common in these two. So when you take 3x common, only x will be remaining here and only 1 will be remaining here. So that means x plus 1. Here you can take minus 4 common. So when you take minus 4 common, what will be remaining inside? X plus 1 will be remaining inside, because minus 4 into x will give you minus 4x. Minus 4 into plus 1 will give you minus 4. So here you can see x plus 1 and x plus 1 are common. So when you take x plus 1 common, in the bracket you will have 3x minus 4. So x plus 1 and 3x minus 4. So p of x is equal to 3x plus 1 into 3x minus 4. So x plus 1 is one factor and 3x minus 4 is another factor of this particular polynomial 3x square minus x minus 4. Similarly, you can solve second and third question in this particular fourth question. So coming to the fifth question, in fifth question I'll solve the first question. In the first question you have x cube minus 2x square minus x plus 2. Here you have a cubic equation and you have to factorize this particular cubic equation. So here also remember, three factors will be there for this particular cubic equation. So now you have to factorize this particular cubic equation. So always remember the constant which is there. Just try to find the factors of this particular constant. So what is the factors of this constant? You have to multiply this constant with the coefficient of x cube as well. So here the coefficient of x cube is 1. So 2 into 1 is 2. So now you have to find out the factors of this particular 2. So what are the factors of this particular 2? 1 and 2 is the factors of this particular 2. Now you have to see which will give you 0. So whether p of 1 will give you 0 or p of 2 will give you 0. So you substitute 1 in this particular x positions and also substitute 2 in this particular x positions. So when you do that, x in the place of x you can take 1 cube minus 2 into 1 square minus 1 plus 2, which is equal to 1 minus here 1 square is there, so 2 into 1 square is 2. So minus 2 is there, so 1 minus 2 minus 1 plus 2. So here plus 2 minus 2 get cancelled with each other. 1 and minus 1 gets cancelled with each other. So you are getting 0. So p of 2 is nothing but 2 cube minus 2 of 2 square minus 2 plus 2. So when you solve this you get 8. 2 2s are 4. 4 into 2 is 8. So minus 8 minus 2 plus 2. So here plus 2 minus 2 minus 8 plus 8 gets cancelled with each other, 0. So that means here x minus 1 is also the factor and x minus 2 is also the factor, because 1 and 2 are the zeros or root of this particular polynomial. So here we have find out that p of 1 and p of 2 is equal to 0. So that means 1 and 2 are the zeros or root of this particular polynomial p of x which they have given here. So that means one root is x minus 1 and another root is x minus 2. Here in the cubic polynomial you have three roots. In order to find out that, now we will write that polynomial once again, x cube minus 2x square minus x plus 2. So you have to split in such a way that you will get x minus 1 and x minus 2 as the common elements. So in order to do that, here you can split this as x cube minus x square minus x square, and this minus x you can split this as x minus 2x plus 2. So if you split in this way, you will get this x minus 1 and x minus 2 as the factors. At least you will get this x minus 1 as the factor of this particular polynomial. So that means here let us take this as p of x, which is equal to, now you can take x square common in these two. So when you take x square common in these two, x will be remaining, here minus 1 will be remaining. So x square into x minus 1. Here you can take x common in these two terms. So when you take minus x common in these two terms, here x will be remaining, here minus 1 will be remaining. So x minus 1, because minus x into minus 1 will be, minus into minus is plus, x into 1 is x. So that means plus x you are getting here. So here you can take 2 common. So 2 into, so minus 2 common. So when you take minus 2 common, inside there will be plus x and minus 1 will be remaining, because minus 2 into minus 1 will become plus 2. So that's why I can take like this. So here you can see three terms are there. One is x square into x minus 1, one is x into x minus 1, one is 2 into x minus 1. So here you can take x minus 1, here you can take x minus 1, here you can take x minus 1 common. So in all these three terms you have x minus 1 as common. So that means here I can take p of x is equal to x minus 1, I can take common. So when you take x minus 1 common, what will be remaining? X square minus x minus 2. So here you have x square minus x minus 2. So now again you can factorize this particular quadratic polynomial which you have got here. So x square minus x minus 2. So here minus 2 is there, so you have to see minus 2 into 1 because coefficient of x square is 1 here. So 1 into minus 2 is minus 2. So when you do minus 2 into 1, it is minus 2. So you should look for such a term a plus b which will give you minus 1, and this a into b should be equal to minus 2. Similarly, how you factorized for previous problems, like that you can solve for this x square minus x minus 2. So that means x minus 1. So here you can write this minus x as minus 2x plus x because minus 2x plus x will give you minus x. So now x minus 1 is there. You can take bigger bracket here. So in this two terms you can take x common. So when you take x common, inside bracket you will have x minus 2 plus here you can take 1 common. So when you take 1 common, it will be x minus 2 only. So because plus 1 into x is plus x, plus 1 into minus 2 is minus 2. So now you can see x minus 2 and x minus 2 are common in these two terms. So you can take common. So x minus 1 will be there outside bigger bracket. So inside bigger bracket, x minus 2 I am taking common. Into here what will be remaining? X and 1 will be remaining. So that is x plus 1. So that means here we are getting p of x as x minus 1 into x minus 2 into x plus 1. So x minus 1 into x minus 2 into x plus 1. So these are the three factors of this particular polynomial. Now I'll try to solve the third question in this particular fifth question. So now we'll try to solve the third question in this fifth question, that is x cube plus 13x square plus 32x plus 20. So in this entire factorization you have to do lot of trial and error, then only you can try to factorize this particular polynomials. So only thing which you should practice in this particular exercise, in this particular factorization, is to do lot of trial and error method. So when you solve lot of problems like this, you will be well versed in trial and error, so that you can easily factorize these kind of cubic polynomials. Now we have 20 as the constant and 1 as the coefficient of this particular x cube. So that means 20 into 1 is equal to 20. Now try to find out the factors of this 20. So that will be nothing but 1 is the factor of 20, 2 is the factor of 20, 3 is not the factor, 4 is the factor, 5 is the factor, 6 is not the factor, 7 is not the factor, 8 is also not the factor, 9 is also not the factor, 10 is the factor of this particular 20. So these factors are there for 20. Now you have to do trial and error in order to find out p of what factor will give you 0 for this particular polynomial. So that is nothing but p of 1, which is equal to 1 cube plus 13 into 1 square plus 32 into 1 plus 20. So when you do this, 1 plus 13 plus 32 plus 20. So that means here you are not getting this particular value which is equal to 0. So that means this particular value is not becoming 0. Now we will try to find the p of 2, p of 4, p of 5, p of 10. So when you do that, here clearly you can see whichever number you substitute here, if you substitute 2, if you substitute 4, if you substitute 5, if you substitute 10, you will not get the factors, because here everywhere plus 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 is there. So even if you put the plus factor over here, you will get the greater value, you will not get 0. So that's why all these positive values are not the factors of this particular polynomial. Now for this 20, minus 1 is also the factor, minus 2 is also the factor, minus 4 is also the factor, minus 5 is also factor, minus 10 is also factor. Now you have to find out the factors of this particular 20. Now these are the negative factors of 20. So now you have to see which of this will give you 0. So that means p of minus 1 we have to try to solve. So p of minus 1 is nothing but minus 1 whole cube plus 13x square is there. So that means 13 minus 1 whole square plus 32x is there. So 32 into minus 1 plus 20. So when you solve this, this is minus 1 plus 13 minus 32 plus 20. So now we are getting this. So that means minus 1 plus 13 minus 32 plus 20. So minus 1 plus 13 is plus 12. So plus 12 plus 20 is plus 32. Minus 32 is also there. So you'll get 0. So that means here p of minus 1 is equal to 0 means x minus of minus 1 is the factor of this particular polynomial, which is nothing but x plus 1. So x plus 1 is one factor of this particular polynomial. Now we have other terms also. Here we have minus 2, minus 4, minus 5, minus 10. We'll try to find out for these as well, because always you have to remember that 3 factors will be there for a cubic polynomial. So that means 3 roots will be there for this particular cubic polynomial. So we have found out one particular factor of this particular polynomial. Now we'll try to find out other factors also. So here in this question I will not do the splitting method, because splitting method will be little bit difficult. So straight away you can do the trial and error and find out p of minus 2, p of minus 4, p of minus 5 and p of minus 10. Whichever will be equal to 0, those are the factors of this particular polynomial. So now we have found out p of minus 1 has given us 0. So that means x plus 1 is the factor of this polynomial. Now we'll try to find out p of minus 2. So p of minus 2 is minus 2 whole cube plus 13 into minus 2 whole square plus 32 into minus 2 plus 20. So when you solve this, you will get minus 2 whole cube is minus 8 plus 13 into minus 2 whole square is plus 4. So 13 into 4 is 52. So 32 into minus 2 is minus 64 plus 20. So here you can see 52 plus 20 is plus 72. So plus 72, 64 minus 8 is minus 72. So that means here you are getting 0. So that means p of minus 2 is also equal to 0. So that means x minus of minus 2 is the factor of this particular polynomial, that is nothing but x plus 2. So we have found out the second factor. Now we'll try to find out the third factor also. So the next factor which we have to try here is p of minus 4. So p of minus 4 is nothing but minus 4 whole cube plus 13 into minus 4 whole square plus 32 into minus 4 plus 20. This is anyway not equal to 0. So p of minus 4 is not the factor, that is x minus of minus 4 is not the factor of this particular polynomial. We'll try the next one, that is p of minus 5. So when you do p of minus 5, this is nothing but minus 5 whole cube plus 13 into minus 5 whole square plus 32 into minus 5 plus 20. Here you are getting answer as 60, which is not equal to 0. So that means this minus 5, that is x plus 5, is also not the factor of this polynomial. Now we will try to do the last factor, that is p of minus 10. So p of minus 10 means this is like very tedious work to do. So you have to do lot of practice so that you can solve this particular questions. So minus 10 whole cube plus 13 into minus 10 whole square plus 32 into minus 10 plus 20. So you can do this. You can also use the splitting method instead of doing this trial and error for everything. So either way, whether you are using splitting method or you are using this particular factor theorem, in both ways you have to do a lot of work to get the factors of this particular polynomials which they give. So in exams, if you want to solve this particular polynomials quickly, if you want to solve the factors of the polynomials given quickly, then you have to solve more and more problems. So here when you solve this, you will get minus 1000 plus 3300 minus 320 plus 20. So when you solve this, minus 320 plus 20 is nothing but minus 300. So minus 300 minus 1000 is minus 1300 plus 1300. Here you can see we are getting 0. So that means here p of minus 10 is equal to 0 and we have got p of minus 1 as 0, and we have got p of minus 2 as 0. So that means x plus 10 will be the factor, x plus 1 will be the factor, x plus 2 will be the factor. So that means this particular p of x can be written as x plus 10 into x plus 1 into x plus 2. So this is the factorization of this particular third polynomial which they have given in this fifth question. So second and fourth question in this particular fifth question you can solve on your own. So this is all there in this particular video. The next concepts which are there in this particular chapter I will be teaching in my next videos. Until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.